This video is for Hillary. This is number 6 from your previous exam. So here are the two functions, and we're rotating it about the x-axis, and they asked us to use cylindrical shells to solve for it. So the first thing I do is I graph the two functions. The x plus y equals to 4 is the black line, and the x equals to y squared minus 4y plus 4 is the red curve. And they asked me to rotate it about the x-axis using cylindrical shells, so therefore I need to create a rectangle that is parallel to the x-axis. So therefore my rectangle is going to go horizontally. Now looking at your rectangle, that means the width of the rectangle is dy, so everything has to be in terms of y. So notice this curve is already in terms of y, so we're all good. This line is not in terms of y, so we solve for y and we get x equals to 4 minus y. All right, so now that we have the picture, we're going to use the formula for cylindrical shells to find the volume. So this is probably the hardest step, setting up the problem. So 2 pi r times f of y dy, and it goes from c to d bound since we're doing it in terms of y. Notice here the points of intersection on the y-axis is from 0 until 3. And how did I know that? Either you graph it on a graphing calculator and figure out where it intersects, or you set the two equations equal to each other and find the points of intersection. So they intersect at these 2 points, and we're using the y values. All right, so I wrote here the definition of r and the definition of f of y. So remember that r is the distance from the rectangle to the axis of revolution. So the distance from this rectangle here to the axis of revolution is simply just y, because this rectangle is constantly moving, so the distance from bottom to top is y. So this r here, I'm going to call that y, and f of y is the height of the rectangle. So the height of this rectangle is going to go from right minus left. So the black line minus the red line. So right minus left. So here you go. The bounds are 0 to 3. The radius is y. The black minus the red. So once I get this, I think that was probably the hardest part of the problem, setting it up. Then I use simplification and finding the antiderivative. So here, I'm not going to explain this part because I think you probably know how to do this part. You simplify it, you get negative y squared plus 3y. You multiply the y through, distribute it. So once I get to that point, I use the fundamental theorem of calculus to find the antiderivative and plug in the bounds. So I'll take a picture of this and post it up as well if I'm going too fast on the video. And long story short, you plug it in, you end up getting 27 over 2 pi. Hope that makes sense. Let me know if you have any other questions.